Hello everyone and welcome to task number 4. In this task, we are going to create our training and testing data set. So let's get started. All right. If you guys remember from the previous task that we have been able to perform some exploratory data analysis and we have done some visualizations as well to the data. So we went through some mini challenges, we did pair plot, we did some histogram as well, and we have been able to plot the correlations as well. And we checked out reg plot or regression plot within Seaborn to try to fit a perfect straight line for us to fit the training data. So let's go ahead and create our training and testing data set. So what we're going to do here is that we're going to simply take the number of years of experience column, and that will be my input X, okay? And we're gonna take the salary column, and that will be my output Y. You will find that X here is uppercase and Y is lowercase. Think of this as kind of the normal naming convention that we try to follow when we train any machine learning model. You will find that in general, all the input features, we give them a naming convention, X uppercase and Y lowercase. Okay, shift enter, looks good. Let's take a look at X. Here we go. That's the only column that I have, which is the number of years of experience. Let's take a look at Y. That's my output, which is my salary. Please note that X is my independent variable and Y is my dependent variable. That's my output. And all what I'm trying to do is to come up with a relationship between X and Y. That's all what it is. Okay. Let's check out the shape. So I'm going to say X.shape. That will give me the shape of X. So I have 35 samples by 1. Let's check out the shape of Y. 35 samples by 1. Okay, looks good. And what I'm going to do here is that I'm going to basically convert the X and Y into a NumPy array. And I'm going to set the type to be float 32. Please note that to train our linear learner later on, it will require the data to be in float 32 format, and that's why I'm doing that conversion in here. So let's go ahead and run this cell, and let's take a look at X right now. So now I have basically that's my data in an NumPy array format, and the type here is float 32. And now I'm pretty much ready to do the division. I wanted to split or divide my data into training data and testing data. If you guys remember from the introductory lecture, is that what we do in general is that we take all the data that we have and then we divide them into training data set and into testing data set. The training data set could be used to train the model, and then once the model is trained, what we could do is that we need to assess or evaluate the performance of the model on data that the model has never seen before during training. And this is very crucial, very important. In machine learning, we want to make sure that our models are capable of generalizing the data and not memorizing the data. I don't need to have a student who is memorizing all the questions in the assignment and going to the exam and find the exact same questions on the exam. And it just doesn't make any sense. What we want to do is that we want to have a student, we teach them through assignments and through concepts, and now they grab the concepts. So now they can apply that into new problems that the student has never seen before. And that's the point of having an exam. And that's why, for example, here in the mini challenge, I try to add maybe some additional information that maybe I didn't cover, or maybe not the exact same examples that I showed here before during training per se. Okay, so to do that, we're going to say from scalar.model selection, I'm going to import train test split, and then I'm going to apply train test split, feed it in my input X, my output Y, and I'm going to specify my test size to be 0.2, indicating that I wanted 20% of my data to be allocated for testing. And then that means that 80% will be allocated for training. And that should return X train, X test, Y train, and Y test. Okay, let's press shift enter. Here we go. And now it's time for a mini challenge. What I want you guys to do is to try to split the data into 75% for training, okay? So I want you guys to change the code in here and adjust it to make it 75% for training. And I also want you guys to verify that the split was successful by trying to obtain the shape of both xtrain and xtest. Also, I want you guys to notice or to tell me if you notice any change in the order of the data and why, what happened. Okay, just maybe explore that a little bit. So please go ahead, pause the video, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is to simply set here to have 75% of the data be allocated for training. You need to go here, and that means I need 25% to be allocated for testing, right? So I just changed that to 0.25. Let's run that, looks good. And to verify it, I can simply go ahead and say xtrain.shape, shift enter, and it will tell me I have 26 samples by 1. If you go here, if you press A, that will insert new cells. If I say x_test.shape, shift enter, that will generate 9 by 1. If I add them up, that will give me 35 by 1, okay? All right. So basically I verify that my data makes sense and the split was successful, okay? Because again, when I sum them up, will give me the original number of my data originally. And did I notice any order or any change in the order of the data? Maybe we can check it out. Go ahead and check xtrain. So I can say xtrain, and here we go. So you guys will notice that xtrain, for example, now it has 1.1 followed by 4 followed by 2. Let's go ahead and see if that makes sense. So now, if you guys can see here, the original data, which is x, was basically as follows: was 1.1, 1.3, 1.5. Here it's 1.1, 4, 2. Just it looks like train test split has also shuffled the data. So you will find that even if you take a look at xtest, for example, so if you say xtest, let's take a look at it. Now I have 10.5, 3.2. So even here, 10.5, and then 3.2, just, you know, like it went back, and then I have, what do I have? I have 5.9 after, and then I have 5.9. So it looks like we got a sample from here, 5.9. So again, it's all over the place. And that's basically what train test split does. It actually split the data for me, and it shuffled the data as well. Shuffling is important when you train any machine learning model to make sure that the algorithm does not learn the order of the data. I don't want the algorithm to learn the dependency or the orders of the training data, and that's why we need to make sure that we shuffle the data. For example, when we train a deep learning model, for instance, to classify, let's say, images of cats and dogs, we want to make sure that we don't have all the images of cats back to back, okay? I want the algorithm to see images of cats and then dogs and then maybe cats again and maybe a couple of dogs and so on. So by doing so, the algorithm will be able of generalizing on the training data much better and try to avoid learning kind of the order of. For this task, I hope you guys enjoyed it. In task number 5, we are going to train a linear regression model in scikit-learn. And please note that we haven't used SageMaker built-in algorithms just yet, and that will happen moving forward later on in task number 6 and 7. So that's all what I have. Please enjoy AWS SageMaker practical course, and I will see you guys in the next lecture.